So if there is anyone left over, just mail me. If you didn't receive the Dropbox invitation, just mail me. Okay. So where did we stop in the last class? We were talking about the data types. So that is where we have stopped in the last class. So today we'll move ahead. Today I'm going to talk about flow control. Um, Hi Vani. Hi Vani. Could you please mute your mic? So you're yet to mute. You'll find that mic option. Okay, thank you. The only issue is that I want to just reduce this background noise as much as we can, so that the records will be uh, very clear without any disturbance. Yeah. Okay. So yes. So I'm just starting. So today we'll talk about flow control. Okay, flow control. So before that, I'm sorry. I'm yet to do. I've got a small topic which I need to talk about regarding the data types. That is type conversions. Type conversion. So you'll find that we have two different types of type conversions. One is implicit conversion and explicit conversion. Implicit and explicit conversion. So these are the two conversion types which you got here. So let's see what is this conversion. We'll consider an example for this. Here, for suppose, let's say we got a byte variable which holds a value 10. So I'll declare another variable here, I integer type. You see this I is integer type variable, and to this variable, you see, I'll assign this value. I'll assign the value which is stored in this byte variable. Yes. Can we do that? Can we assign a value of one type to another type here? Yes. So the thing is, in few cases it is possible, and in few cases it is not possible. For example, in this case, yeah, it is very much possible. You know what, here this byte variable, you see, it holds an integer value itself, and the range of byte is always within the range of integer. The range of byte is always within the range of integer. Yes. So whenever we try to assign a byte variable value to integer type, so first of all your Java will check this. Okay, it will try to upgrade this byte to integer type, so that 10, it will try to upgrade it, and it will store it into that. It upgrades it to integer type and stores it into this variable. You see, when it converts, upgrades or converts, I can say, from it converts that byte value to integer type. So in this conversion, is there any loss of data? In this conversion, is there any loss of data? So you see, in this conversion, there is no loss of data. There is no loss of data in this conversion, right? Yes. So Java will do it implicitly. That means we don't need to ask Java to explicitly, or we don't need to tell Java to do this. It does that implicitly, I can say. Okay. Yes. Without our involvement, it does that. So this type of conversion is called as implicit conversion. Yes. You see, if you try to print that value, okay, you'll get this as 10 itself. Okay. Now, similarly, for suppose, let's consider another example. Let's say you have integer variable. So you got a float variable. Okay. Yes. Now I'll assign that integer value to float type. So again, these are two different types. One type of value we are trying to assign it to another type of variable. Yeah. So even now, so Java will try to convert that integer value to float type. So this time, when that integer value is converted to float type, yes. So how it is represented? What do you people think? How that integer value is represented as float type, float value 10.0. Yes. So it will be represented as 10.0. Point decimal floating point value will be added. Okay. As of now, it will be 0. Yes. You see, in this conversion also, there is no loss of data, right? So there is no data truncation, or there is no loss of data in this conversion. You see, because in this conversion there is no loss of data, so Java again it does that. It will go ahead and will do this conversion. Okay. Yes. So without any issues. Yeah. Now you see, if we try to print that value, float variable value, so it should print 10.0. Yes. Okay. So now this is about implicit conversion. See, let's see explicit conversion here. See, in implicit conversion, we don't need to write any code explicit in extra code to ask the Java to do this conversion, to convert from one type to another type. Okay. Yes. It does that. For suppose, let's say I got a float variable here, and this is the value which you got here in this float variable. It's a 10.25. Yes, we got this. Just sorry. Okay. Yes. You see, you got a float variable, and this is the value 10.25. Okay. Yeah. So yes, Rupa, we are talking about type conversions. Yes, type conversions. So this is a variable now. Now let's say we got another variable here called as int I. We got a variable called as I, which is of type integer. Now what I will do is here, we'll try to store that float variable value, or we'll try to assign that value which is in float variable to that integer variable. Yes, one type of value, we're trying to store it into another type of variable here. This is where the type conversion comes into the picture. Yes. So this time, you see, will it allow us to do this? So this time we are getting an error. This time we are getting an error. Yeah. So what is that error? Why we are getting the error here? Let's see. This time also, first of all, Java will try to convert that float type to integer type. If that float value is converted to integer type, if float value is converted to integer type, then how is that float value represented uh, if it is integer type? 10. Yeah, just a minute, please. Just a minute. Okay, sorry. Yeah, hi Ravi. Can you hear me? I guess this is your first session, so just want to check with you once. I just noticed you. Yeah. Okay. Hope you can hear me, right? I'll just talk to you after the class. I guess I can't hear you. Are you speaking by any chance? Can you hear me? Okay, fine. So I'll talk to you after the class. Okay. Yeah. So, okay, cool. So yes, you see now that float value, if it is converted to integer type, yes, so it will be only 10, just 10. That means that the decimal value which you got here, it will be truncated. 0.25 will be truncated. That cannot be stored. We cannot assign that value 0.25 into that integer variable. Yes, it's not possible. Yeah. So that means in this conversion here, there is loss of data. In this conversion, we got loss of data, right? So that's the reason why Java will not do this conversion implicitly. That means on its own, it won't make a decision to do this conversion. You see what it does? It won't do this conversion on its own. It is not going to do this. Yes. So it simply throws an error because in this conversion there is loss of data. Yes. If it does this conversion, there is loss of data. So that's the reason why it will not proceed with this conversion. It simply throws an error. That is what is the error here? You see, type mismatch, cannot convert from float to int. Yeah. But now here, I would like to explicitly ask Java. Okay, I would like to ask Java to do this conversion at any cost. Okay, I want Java to do this conversion at any cost. Yes. So how can we ask Java to do this conversion at any cost? Yes. So that is where the casting operator comes into the picture. You got a casting operator. Okay, this is a casting operator, brackets. Okay, to what type you want to convert, that data type you have to specify it here in this casting operator. To what type the value has to be converted, that you need to specify that casting operator. Yes. So now let's use this casting operator, and we'll ask Java to convert that float type to integer type here. Okay. Yes. So you see in this variable t, we have that float value. So it has to be converted to what type? Now you can specify it here in this casting operator. I want it to be converted to integer type. That's it. So this is what you're going to do. Yeah. So now let's try to, that means here we want that float value which is stored in this variable t to integer type and assign it to this integer variable. So let's try to print that value. So this time you see it prints only 10. So data is truncated. Yes. But still it is doing the conversion because we are asking Java to explicitly do this conversion here. Okay. Yeah. So hope everyone got it, right? So any questions in this regard, please let me know. Okay. So shall I assume that this is clear for you people?
Yes.
Okay, cool. So let's move on. Now we'll talk about flow control here. So you understood this type conversions. So Java will do implicit conversion. It converts from one type to another type if there is no loss of data. Implicitly, you know, it does that conversion if there is no loss of data. But whenever there is loss of data or data truncation takes place, in that case, we have to explicitly ask Java to do that conversion. Yes. Next, we'll talk about flow control. So, flow control here, flow control constructs, I can say, uh, they're going to help us in defining the execution flow. The flow control constructs will help us to write the execution flow, wherein you can have decision making. Okay, so you can write the code which makes some decisions based on the input, and it does branching. That means based on the decision, uh, it can execute a task. Okay, or based on the input, it may take a decision which task to execute or what set of instructions has to be executed. Yes, that kind of thing, that kind of execution flow we can define here using this flow control constructs. Yeah, so almost every programming language will provide you this flow control constructs, okay, which helps us to write the code execution flow, okay, which helps us to define the execution flow, where you'll have decision making, branching, and all such things. Fine. So here when we talk about flow control constructs, we can broadly classify them into two types. One is conditional constructs, and the other one is looping constructs. conditional constructs and looping constructs. Yes. So conditional constructs, you'll find that further they're divided into four types. We got four different types of conditional constructs. What are they? Let's see. So this conditional constructs are similar to your C++ conditional constructs. So you got simple you got if else if, and switch. And when we talk about, sorry, just a second. And when we talk about looping constructs, again further they are divided into four types: while, do while, for loop, and for each. So these are the four different types of looping constructs. Yeah, and conditional constructs are also four different types. Now, what is the difference between conditional constructs and looping constructs? You know, conditional constructs will help you people in decision making, I can say. So, based on the input, now you can decide whether to execute this set of instructions or another set of instructions, or whether to execute a particular set of instructions or not. So, such decision making you can do that using conditional constructs. Yes. Whereas looping constructs, we use them whenever we are supposed to execute a task, a particular task, when we are to execute it finite or infinite number of times. When we are supposed to execute a task finite or infinite number of times, then we'll use looping constructs. Yeah. Okay. Yeah. So that means repeatedly, if you have to execute a task, then you'll go for looping constructs. Now, first of all, we'll start our discussion with conditional constructs. You see, the first one here is simple if. So the syntax of simple if. So this is a syntax. If condition, and you can have a block associated to this if condition, and in that block you'll have set of statements. So this condition here generally will be a Boolean expression. The condition which we'll write here will be a Boolean expression. So what do we mean by a Boolean expression? What does that mean?
Okay, true or false. Conditions like uh,
Yeah. So yes, an expression.
you initialize.
Yeah, tell me. Yes, Siri.
No, no, go ahead, go ahead.
Okay. Okay. Yeah. So yes, this sort of expressions I double equal to 10. The expressions, uh, when they're evaluated, the result of that expression when it is evaluated, it should be either true or false. Okay. When an expression is evaluated, the result of that expression, if it is either true or false, such expressions you can call them as Boolean expressions. So this if condition here always takes a Boolean expression itself. Examples, yes. You see, yeah, that I equal to 10, or I less than some other value. Let's say I less than B, sorry, A, not I. Say B greater than A. Let's say we got two variables, A and B. You see this expression A double equal to 10, it will compare that A value with 10. So A value can be anything. If that A value is equal to 10, then the result will be true. This condition is true. That statement is true. That Boolean expression, always you see, it either evaluates it to either true or false. That's it. The same is the case for others also. If A is less than B, then this expression will be true, or else it will be false. If A is not less than B, then it is false. That statement is false. The same is the case for B greater than A as well. Okay, such expressions. So they are Boolean expressions. Normally, that Boolean expressions are expected here in the conditions. Okay, normally Boolean expressions are expected here. Fine. So if this condition is true, then only the block associated to this if condition will execute. If that condition is true, then only the block associated to that condition will execute. In that block, you can have any number of statements. Okay, yes. So what if that condition is false? Then the block won't execute. Okay, yeah. So let's take an example here. Let's say int number of days in a year. Number of days in a year. Let's say if it is, let's say just 365. You see, let's say if number of days is double equal to 366, then it's a leap year, right? So we'll print a statement, leap year. I just would like to print that statement, leap year. Yeah. So if number of days in year, if it is 366, then I want to print leap year. That's it. Okay, as of now, you see in that variable, you see there is a difference here between this assignment operator. So single equal to, if you use single equal to, it is assignment operator. So whatever the value you got on the right side will be assigned to this variable on the left side of the assignment operator. Okay, if you use single equal to, it is assignment operator, it is not comparison operator. Okay, please remember, if you use single equal to, it is a assignment operator, not a comparison operator. So what it does, it assigns the value which is on right side of that operator to the variable which is on the left side of the operator. That's it. Now that's 365 will be assigned to that variable number of days. That means in this variable now we got 365 number of days in a year. That value of that variable is 365. Here now we are using double equal to in this expression, so which is a comparison operator which is used to compare the values. Now what this relational operator does, double equal to, it will compare the value which is in this variable with this value 366. Yeah. So as of now, that value which is in that variable is not equal to 366. So this expression is false. So the block will not execute. Okay. So if I run this code, what will be the output? What I'm going to get here, what will be the result if I run this code? So it prints nothing. The console will be blank. You won't get anything. Yes. You see, the console is blank. Generally, you see, this simple if, you can only use simple if. Okay, if you want to execute a condition, sorry, if you want to execute a task, if that condition, uh, if a given condition is true, that's it. Otherwise nothing happens here. Yes, there's no else part here. Okay, so that is about simple if. Yes, if the condition fails, there's nothing to do here. Yes. Next, we got the second type of loop, sorry, conditional construct, that is if else. If
If
else.
else.
If else. So I can say that if else is an extension to else if. Sorry, simple if. See, in case of simple if the condition fails, we don't have any option to execute any alternate task, right? If the condition fails, we don't have any alternate to execute a task. Yes. If the condition fails, there's no alternate task to execute here. Yes. But in case of if else, you see, if the condition fails, yes, we can execute an alternate task here in this case. So we can do this. Statements. So if the condition is true, then that immediate block here will execute. If the condition is false, you see the else block will execute here. That is what happens. Okay. So for suppose here, in this case, you see we can add a else part here. See if it is not 66, so you can print a message, not a leap year. Yes. So this time, what happens? It prints not a leap year. So earlier the output was blank. Now it prints not a leap year. This is if else. So I guess they're simple to understand. Hope you don't have any issues, right? Yeah. So shall I move on to the next type of conditional construct?
Yes.
Okay. So hope everyone got it. So the next one is if else if. So in the case of if else if, you know what? For the else block also, we can add a condition. For the else block also, we can add a condition. That means the else block only executes if that condition is true. Yes. The else block only executes if the condition is true here. So you can add any number of else if blocks here. Okay. There is no limit. Else if blocks, you can add any number of else if blocks here. Okay. So let me give an example for this. For suppose here, we got two variables, int a variable a with some value, and b with some value. Okay. Yes, you see, we can declare multiple variables in a single line, in a single statement. That won't be an issue. Now, what I want to do is here, I would like to compare these two variables and print a message. Which variable holds a value which is greater or smaller, or which values, whether A is greater or whether B is greater, or whether both are equal. I just would like to do this. Yeah. So let's try to do this. Now you see we got three possibilities here. What are they? A can be greater than B. Normally A can be greater than B, or B can be greater than A, or both can be equal. So we have to check for three conditions, right? Okay, so let's do this here. If A is greater than B, yeah, yes, yes. So I'm talking about if else if, okay, if else if, where for the else block also will have a condition. That is what I'm discussing, okay? Yeah, if else if, yes. So now we are trying to compare these two variables A and B. That is where we'll use if else if. Yeah. So now if A is greater than B, I would like to print a message. A is greater, else if B is greater than A, I would like to print B is greater. Okay. Now, what if these two conditions fail? What if these two conditions fail?
Else if
That means both are equal. Am I right? If A is not greater than B, and if B is
yes.
not greater than A, in that case, I can say that both are equal, right? So, do we need to check? Sorry, do we need to check for that condition explicitly? Are we supposed to do that?
No.
So we don't need to do that here, not needed. So what we can do is here simply we can use a else block. If you want, you can do that, but not needed. If the two conditions are failed, above two conditions are failed, that means there is only one possibility, both are equal. So you can simply, print that message. A and B are equal. Yes. Yeah. So this way, one thing what I want you people to notice is here for the else block also we can add if condition here. See, for the last else block also you can add a condition, though it is not needed, but yes, it is possible. Just want to show you people once. We can do this. You see, you can add any number of else if blocks, okay, based on your requirement. Yeah, as of now in this requirement, one else if block is enough, and one else block is enough here. Yes, that's it. So let's run this code. So hope you people got it. Yes. So anyone got any questions in this regard? Please let me know. Okay, good. Just a minute, please. Just a minute. Okay. Hello. Can you people hear me? Okay, good. So let's continue. Now we'll talk about switch case here. Okay, switch. So switch is the fourth type of conditional construct. So it is slightly different from the other conditional constructs which we saw. Okay, just a second. Mic. No. Okay, sorry. Yeah. So let's go through the syntax of the switch case. Usually for the switch you need to pass a selection value. In the switch basically you'll have several cases. Each case will have a value, say case 1. For each case you'll have set of statements associated. Yeah. So you see, to this switch a selection value will be passed. Normally it can be any integer value, or it can be a character, or it can be a string, not a floating point value. So that value, when it is passed on to the switch, you'll find that the switch here will take that value and will try to compare that value with one of the case values. Okay, you see, for each case you'll have a value associated here. Yeah, hello.
Hi bro, this is Gnaneshwar. I can't see your screen, bro.
Okay, others, are you people able to see my screen? Okay, others are able to see Gyaneshwar. I guess there is some issue from your side. Could you please check once?
I
So
mean,
what
what
is
do you want me to do? Do
uh,
you want me to
yeah, try.
rejoin the meeting?
Yeah, I guess that is better. Yeah, try
Sure,
to
thank you.
rejoin. Yeah.
Okay.
Okay. So you see, we'll see. It's not always mandatory. Okay, that's the reason why I didn't add it. It's not mandatory. Yeah. Okay. So let's resume the explanation here. You know what? The selection value which is passed here to the switch. Now, if it matches any of these case values, for every case you will have a value. See, if that selection value, if it matches any of the case value, then what happens? That particular case will execute here. Yes, that particular case is going to execute. Fine. What if that selection value, if it doesn't match any of these case values? The selection value, if it doesn't match any of the case values here, if it matches none of the case values, then what happens? The default case executes. You see, for each case, you can have set of statements associated to it. When I say a particular case executes, that means the statements which are associated to that particular case are going to execute here. Yes. Yeah. So now let me show you people with an example. For suppose, let's say we got a switch. I'll declare a variable here. Let's say int I equal to some value, say 15. Say 10. So that I value is a selection value. We'll pass it to the switch. In the switch, you'll have cases. So each case will have a value. So first case value is 5, let's say. And I'll add a statement here. I values 5. Second is I values 10. And I values 15. Then I'll add this default case. Okay. So now you see this I value is a selection value which is passed on to the switch. So now that I value matches this second case 10 value. I value matches that second case value 10. Yes. So that particular case statement, the statements which are associated to that case will execute. So in this case, it prints I values 10. And then we got a break statement which instructs the control to stop executing the switch. So the switch won't execute any further. The control comes out of the switch case, I can say. The control comes out of the switch case. Yeah, so whenever the break statement is encountered, so the switch will stop execution. The control comes out of the loop here. That's it. Control comes out of the loop. So in our example, so it just prints I value is 10 and you got a break statement. So it will stop execution here. Yes. Hey Tarun, hi. You're late today, I guess. Got some work. Okay. So what if I don't add break statement here? For suppose there is no break statement for case 2. So if there is no break statement here, then what happens? The next case also executes. The case which follows that case, which follows case 10 also executes. That means case 15 also executes. And then you see in case 15 you got break statement, so it will stop execution here. What if there is no break statement here in case 15 as well? There is no break statement in case 15. Then the default case also executes. The next case, whatever case you got, when those cases will execute here. So that is how it works. Yeah. So if I run this code, this time it prints I value is 10 and I value is 15. Okay. Now what if I value is 100? Now none of the case values matches that I value, right? So in this case, what happens? The default case executes. You see? Default case. Yeah, that is what happens. Okay, fine. Now you might be wondering, so why we need this kind of feature without a break? So if we don't add a break statement, then it becomes meaningless, right? Sometimes, see in this case, if I value is 10, and if I don't add a break statement, then what happens? It prints both I value is 10 and I value is 15. So when do we use this switch without a break? When can we use the switch case without break statements? Yeah. Okay. So I'll show you people an example. So where you can use this, let's see. So the best example for this is, for suppose, let's say you got a character or alphabet. So whenever an alphabet is passed to the switch, okay, let's say we'll pass alphabet to a switch, and the switch should take that alphabet and it should check whether it is in small case or in uppercase. Okay, it should check whether that alphabet is in small case or uppercase and accordingly print the message. That is my requirement. Okay, so what is the requirement? So we'll pass an alphabet to the switch case. So it has to take that alphabet and check whether the given alphabet is in small case or uppercase here. So that is what we are supposed to do, let's say. Okay, yes. So let's see. In this requirement, you'll understand how that break, without a break, the switch will be helpful for us. Say I got a character, something like this, B. Now I'll write a switch which takes this character, which is an alphabet, and checks whether it is in small case or uppercase. CH. Sorry. So you see, now in this example, for set of cases, we got the same task to execute, right? For all these cases, we got the same task to execute here. For all these cases, we got the same task to execute. Yes. Now you see, similarly, I can do the same here for small case letters also. Yeah. Yes. So what happens, you see, if the given character value, if it is one of the case values, sorry, if it is one of the case values, then this task has to be executed. You see, in this case, we don't need a break between those cases. But after this statement, you need a break. Yeah, just a second. Sorry. Yeah. And similarly, if the given character value, if it matches any one of these case values, then I want this statement to execute here. That's it. So hope you people got it. Actually, we can write the cases till Z from A to Z also. That's not a problem. But as of now, I've just written it till D. Okay, see, actually, if you want, you can write all these cases in a single line also because there is no break statement. For all these cases, we got the same task to execute. You can also do this. It works. Okay. So, hope you people got it. So let me run this code.
Mahesh,
Yeah,
okay. Could you explain the break again for me?
yeah. Break. It simply terminates the switch case. That's it. Whenever break statement is encountered, the switch will stop execution. That's it. The control comes out of
So
the switch.
out of the loop,
Out of the switch. This is not a loop.
switch.
This is not a
Okay.
loop.
Yeah.
This is switch.
Yeah. Yeah. Okay.
Control comes out of the loop. Comes out of the switch here, not loop. Yeah.
Okay.
So hope you people got it. Okay. So without break also sometimes it is useful to use the switch without a break. You see in this requirement, this is the example for that. In some cases you may need to use break. Yeah. So anyone got any questions here? Please let me know. Okay.
Please execute it.
Yeah, we have executed it. You see, given alphabet it says is in uppercase. Okay. So it says given alphabet is in uppercase. Fine. Now you know what? This without using switch also we can execute this task, or we can actually, you know, implement this functionality here. Can you people tell me how to do that? So we can use one of the conditional constructs which we discussed earlier. Before switch we have discussed about few conditional constructs, right? Without using switch, we can use one of the conditional constructs to achieve the same thing. Yeah, same task. Yes, if else if.
If else if.
Yes, yes, if else if. That's right. You can use if else if. Okay. But which one is better, if else if or switch in this case?
if else if is much easier.
I guess switch is better because you see, you don't need to write many conditions here, right? So otherwise, you can try writing if else if. The number of conditions which you need to write will be more. Yeah, so you can just check that. And looks little complicated. This one looks easy, a lot easier. Okay, you can try that also. You can compare them.
Okay.
Yeah, fine. So this is about a switch case. So hope everyone got it. Fine. If so, I'll do one thing here. We'll stop the session here today. Okay, and yeah. So this is just last 1 hour session for today, and from Monday onwards, we'll meet at same time, but it will be 2 hour sessions. Okay, from Monday onwards, our sessions will be for 2 hours. So first weekend, we'll take break to tomorrow and day after tomorrow, Saturday and Sunday. There is no session, but from next week onwards, we'll have session or we'll have class on Saturday as well. Okay, there is a class on Saturday as well. Yeah, fine. So that's all for today. Okay, so let's meet on Monday again. So this first weekend you'll have break for
Okay.
2 days,
So
but
the next class will be on Monday?
Monday at same time and use the same meeting link. And yes, if anyone
Okay.
is yet to receive the Dropbox invitation, please mail me. Yeah, and Ravi, yeah, so you can just call
Sure,
me on this number. Okay, yes,
sure.
yeah, yeah. Okay, let's take this number. So I'll start.